In part one, I told you that the body temperature of a human being is roughly 37 degrees. So if you were to plot a graph of temperature and time for a human being, it will look something like this. It will hover around the 37 mark. And this here would be one day because it's 24 hours here. This here will be the day after that. Okay, so 2 days here. Now, I also said that the lizard, if you look at a lizard, it's cold-blooded, so that means its body temperature changes with the environment. So in this video, I will try and show you how you can model the body temperature of a lizard. And remember, all this is made up. It might not be true. For you to find out, you have to do some experiments. So you might have to capture lots of lizards and somehow find a way to measure its body temperature throughout the day, throughout the whole day. So you might have to ask your biology teacher on how you can measure the body temperature of a lizard throughout the whole day. So in this video, we're going to say that we're just going to make up that the body temperature of a lizard fluctuates. Let's say it hovers around the 25-degree mark, and then it fluctuates by a factor of, well, this here will be 5. Okay, we're just going to make this up. I don't know what it's like in real life, but here we are just going to make it up. So it hovers around the 20-degree mark by a magnitude of 5. So the highest temperature will be 25, the lowest one would be 15. Well, anyway, we're going to set up this model here. So well, don't forget, we are going to set up so that the period is 24 because it matches up with our day, 24 hours in a day. Because our normal sine graph will have a period of 360. We somehow need to set up so that we have a period of 24 hours. Okay, and also looking at this bit here. Hang on, I'm going to use this as a reference point here. Okay, hang on. So this bit here, I'm going to use this as a reference point. Hang on, bear with me. Well, me using this point here. Hang on. So normally it would start here. So 0, 0 is like midnight. This is midnight here. Midnight is here. Midday is here, and again it goes back to midnight here. But the thing is we're going to say that well, sun rises. Hang on. The sun rises at 5 in the morning. We're going to say the sun rises at 5 in the morning. So we're going to set up this model so that the body temperature of the lizard starts to rise when the sun comes out. So the sun comes out at 5 in the morning. Okay, so somehow we want to set up so that this here is at the 5 mark. Okay, the sun comes out, and then its body temperature will rise, and then this bit here is night time. So at night time, there's no sunshine, so the temperature outside will decrease. So the body temperature of the lizard will also decrease. So the sun rises at 5 in the morning, and then this here will be night time, and then it starts to decrease, and then 5 in the morning again the next day, the sun will come out. And then it will rise again, and so on. Okay, so we're going to set up this model so that it's going to be like this. Hang on. It will hover around about the 20 mark here. Okay, so the 20 mark here, it will hover around here. Okay, but the important thing is that the body temperature starts to rise at 5 in the morning, because we're going to assume that the sun comes out at 5 in the morning. Okay, so let's try and set up this model. Hang on. So start. Well, hang on. Let me start again here. So try and set up the model. So normally our sine of x will look like this, 360. Okay. So this is sine of x. But now we want it so that the sine of x one period is 24. How would we get from a period of 360 to a period of 24? Well, let's look at this here. Hang on. 360. This is 360 here. Okay, so this is sine of x, and that gives us 360. Now, if you have sine of 3x, well, sine of 3x would give us this: 1, 2, 3. Well, then this distance here would be 120. So this here would be 120. But here's the thing: we want somehow to get to 24. So we want sine something. Let's call it a. Okay, sine of a. Somehow we got to find out a that would give us 24. Now, when you look at this case here, when it's 3, you would get 360 divided by this number here, to give you the 120 here. Okay. Now looking at this thing here, we would want 360 divided by this number here, which is a. Let's call it a, and then we're going to try and find out a to give us this thing here, 24. Okay, so now it's just a matter of finding out a. So times both sides by a, and then divide both sides by 24. So a will be this, will be 360 over 24. Okay, so times a and then divided by 24, and then that will give us sine this thing here, because this is a, this here is a. So when you put this into here, if you get a graph plot and do 360 over sine 360 over 24 x here, then it would give us a period of 24 here. Okay, so now hang on, let me clear this. So me doing a graph of sine 24 would look, so this is a graph of sine 360 over 24 x here. It would look like this, and notice that the period here, this is one period here. The period here is actually 24. This here is 24. This is one period here. But the thing is, the body temperature at the moment, the magnitude is only 1. What that means is, our model so far, our model of sine 360 over 24x, our model so far is saying that the temperature fluctuates. Well, it's only varying by 1 degree. So that means that at our 20 mark here, remember, we want to set up. Well, so at the moment, the body temperature of this lizard so far, it ranges between 21 and 19 degrees, which is no good at the moment. But the good thing is that we got our period to be correct, because if you look at sine, well, look at this here. This is 24 hours here, and then another period here. Look at this. This is 48. So by us doing this here, 360 over 24x, by us doing this here, the period is good, but the magnitude is wrong, because we want to set up so that the lizard, the body temperature of the lizard, fluctuate by 5. So around here it will go up to 25, and then it will fall down to 15. We want to set up so it's like this. But so far we've only corrected the period of 24 hours here, which is good. Okay, so the next step is to change the magnitude. To change the magnitude, we want the body temperature of the lizard to fluctuate by 5. So it's hovering around the 20 mark. We want it to go up to 25 degrees, and we want it to come down to 15 degrees. Okay, so now all we need to do is change the magnitude. So far we've got sine 360. So this is y equals sine 360 over 24x. Okay, our next move is to change the magnitude. So that would be this. Okay, so us plotting this graph here would look like this. Hang on. will look like this. Okay, so it was this here, but now we're going to change the magnitude. So notice that it will come up to 5. Okay, so now this is our graph of sine of y equals 5 5 sine what was it, 360 over 24 x here. Okay, but the thing is, we wanted to hover around about the 20 mark. You see, this is 15 here. We wanted to hover around around the 20 mark. So we need to translate the whole graph up by 20, by move everything up by 20. Okay, so our next step is to do this same thing, but to add 20. Okay, so we move it up. So hang on. So me doing that will give us this here. You see, this is our new graph now. Notice that this point here is at 20 because we want to set up the model so that, well, a human being is hovering at 37. So now we want it to hover around the 20 mark. That's why we added 20 right at the end. So far our graph is this: y equals 5 sine 360 over 24 let me think, x, and then plus 20. This is our green line at the moment. Our green line is this. The next thing is we want to set it up so that well, remember, looking at the green line here, remember, we want to set it up so that as soon as the sun rises, then the body temperature of the lizard starts to rise. Okay, so we want to set it up so that as soon as the sun comes out, then the body temperature starts to rise. So we want to somehow move this to the 5-hour mark, because we are saying that sun rises the sun rises at 5 in the morning, 5 a.m. So we want to somehow move this across. But rather than moving that across, I'm going to do it like this. Hang on. Bear with me. Looking at this here. Hang on. Bear with me. So looking at this here, this here is right. Rather than using this point here, I'm going to use this point here. It will still work. If I can move this here to somehow to 5 in the morning, I ultimately want to move this point to 5 in the morning. But let's look at this. Let's look to see what's going on here. Our normal sine of x is 360. By us doing sine 360 over 24, we produced a period like this. Hang on. We produced it like this, so it's 24 hours. Well, if from here to here is 24 hours, then here must be 12 hours, and here must be 6 hours. And then this point here will be minus 6. Okay, so this point here will be minus 6. Now, I want it so that I want to move this point here. Remember, we want to set up so that as soon as the sun comes out, then the body temperature starts to rise. So basically, we want to move this point here to 5 in the morning. Well, if from here to here is 5, and from here to here is 6, then we need to add. Then we need to move it across by 11. Okay, we want to move it across, but we want to move this across by 11. Okay, hang on, by 11. So looking at the green graph at the moment, is y equals 5 sine 360 over 24 pi 24x, sorry, 24x, and then plus 20 earlier to move it up by 20. But now we want to move it across, so we want to move it across by 11. Okay, oops, we want to move it across by 11. So now imagine this whole thing here to be a function. Let's say at the moment we've got a function f of x equals this. Now, if we want to move something across by 11, then we would make this transformation here, minus 11. Remember, to move it across to the right, we would minus So basically we need to put this into where x occurs. X occurs here. So we need to put that x. Well, anyway, we need to put everything, anything that involves x. We need to replace x with this thing here. So put this thing into this x here to produce that transformation. So our new graph y should look like this: 5 sine, and then 360 over 24, and then we've got to put brackets x minus 11 and then close it off. So let's put everything inside square brackets here, so that the whole thing here is this thing here, and then we've got to add the 20 at the end. Add 20 at the end. So here our final equation would look like this. Okay, so our final equation will look like this. So us doing this, hang on. So this is our final equation here. You see, this is when the sun starts to rise here. 5 in the morning. So now it's been shifted across by 5. Okay, and then it's hovering at the 20 mark. So here, this here, yeah, this is a 20. Yeah. So this is our final equation. So our final equation is y equals 5 sine 360 over 24, and then we've got our x minus 11. Okay, and then all this, and then add 20. So this is our final equation, and you can tidy this up, by the way, because first you can simplify this, and you can multiply this out and this out here. You can simplify, but I'm going to leave it as this because just so that you can see what's going on here. Okay, so this is our model of the lizard. Okay, and wait there. What that means is, let's just say around here. No, actually we're gonna, the video's been traveling. The video has been going on for a bit now, so we let's put it to a stop here. So our final model would be this, and you can simplify this. And remember, this is just made up, just to illustrate that you can use maths to model the lizard. And by the way, before I said where there's pie, so where there's smoke, where there's fire, where there's smoke, there's fire. And I also mentioned that where there's pie, there's a circle somewhere behind it. Now here, and also we've seen that even though we've got this sine graph here, behind this is really a circle, because we've got a circle moving around here to produce this thing here. Now you've got a lizard, the body temperature of a lizard that looks like this. Now where is the circle involved in this thing here? Where? So we've got, yeah, we've got this graph here represents the body temperature of the lizard, but behind it all there's a circle. Where is the circle in this? Well, if you think about it, it's going around in a period of 24 hours. So this side, sorry, it's going on. This one here is one period here. Well, yeah. So one period here is 24 hours. Another period is 24 hours here. The circle behind this is really this. The sun is here, and remember, this is a graph of the body temperature of a lizard, and the sun is here. Our Earth is here. You see, our Earth spins around like this every 24 hours. So the circle is really the Earth spinning around in a circle. So the Earth spinning around in a circle gives us this sine graph here. My point is that looking at the body temperature of a lizard is really well, it's caused by the Earth spinning around every 24 hours. So the spinning of this Earth, the spinning of the Earth produces a well, it affects the body temperature of a lizard in a way that we couldn't connect it. Well, anyway, okay, let's call it a day here.